Alright, how would we use Minitab to solve a problem uh, like this one here, 25 on page 276 from the textbook? Uh, got a population mean for salary of 63,500. There's a sample of 35. What's the probability that the mean salary will be less than 60,000? And they give the standard deviation of 6,100. Now, if they hadn't given us the sample size of 35, we could just do a standard z-score, or regular z-score, where it's 60 minus 63.5 divided by the 6,100, you get a z-score, find the probability. But since we have a sample size, that changes the nature of the z-score, and we're actually dividing the standard deviation by the square root of the sample size. So if I take 6,100, find the square root of 35, which should be close to 6, and divide those, I get 1031, 1,031, and some change there. So I'm going to need that number. So when we go into Minitab, the way that we'll do this is under the Calc menu, probability distributions, and a normal distribution. We would get this panel here, and we stick with cumulative probability, and we want to put in the mean value from that problem. But the standard deviation is not going to be the one stated in the problem. It's got to be the standard error of the mean, which we just found to be 1,031, and put that in there. Now the input constant, it's not perfectly clear why you would do this, but what it's looking for is the value that you're testing against, which was 60,000. That's what we're looking at. And so click OK, and we get right here an incredibly small probability of 3/10,000ths and some change. Now another way to see this is to do a probability distribution plot. You want to click on View Probability, and again the mean value will be what the population mean assumed in the problem. The standard deviation has got to be the standard error of the mean, and then we click on, we know it's a left tail because we want the probability that it's I believe less than, if I remember the problem, and instead of a probability we want an x value. So here's again where we put our input constant of 60,000, and it'll give us a graph like that. And that, I must have done something wrong, so it's great. Oh yeah, I had the wrong you can see this probability. This takes us all the way over to the right hand end, and so what's left over on the right hand side is actually the value we were looking for. So almost glad I made that mistake. Let's go back and put in the right stuff. Yeah, I left it right tail. Needed to be left tail. I said left tail and then didn't do it. And so here you can't even see it. And so this could be a little confusing. If you see how I moved that value over, it's given us that same value that we had received over here, but it's such a small area it can't even be plotted. Now let me graph this as if I didn't know that we were dealing with the sample and it was just the regular standard deviation that was reported in the problem of 6,100. And we'll still do the same less than side, the left tail, against 60,000. And here you go. And somebody in the discussion had obtained this value, and it simply was because the sampling error, or the standard error of the mean, was not taken into consideration. One little extra step of dividing the standard deviation by the square root of the sample size changes everything when you're dealing with a sampling distribution. So if you're given the sample size, you've got to divide standard deviation by the square root of the sample size before you do these calculations. But inevitably, if you're going to use Minitab, Minitab hasn't evolved to a point where you could put in the sample size parameter and let it do the math that we did here on the calculator. So there you go.